Hi, I'm James Mahoney. This video is designed to supplement an in-person class. After teaching this class a few times, I heard from students that many found that the animation system in Unity was particularly challenging. In this video, I plan to help demystify it a bit and hope you will learn to love creating animations in Unity. Of course, there are many ways to animate things in Unity. You can do all your animation with code, for example. There's also a wonderful built-in animation system, and as you would expect, you can import animations from an animation system like Maya or Blender, or use some combination of these things. Animating with code, as shown in the Unity Basics development video, is an obvious choice for many animations in Unity. If you're a coder, this is a no-brainer. Simply change parameters like position or scale incrementally over time in an object's update method. In the Unity Basics development video, we created our first component to spin the object it's attached to, the spinning red cube demo. It really could not be simpler. However, as with everything, it takes a bit of imagination to think of all the ways you can use code to change parameters, respond to events, and to make things change in an environment to create something interesting. Remember that most things you'll want to do, others, maybe many others, have also wanted to do that, and Unity has already paved the way. For example, if you want an object to be oriented to point to something in the scene, you can use the very handy lookAt method in the transform class, which takes a transform as input. You can pass in an object and grab its transform, and then have your object point to that target object. If you put this in the update method, you will ensure that the object always points at the target, which is pretty awesome, right? So remember, if you're looking to use code to animate something, check to see if there's an existing method to help you accomplish that goal easily. Let's talk about the Unity animation system. I find that most of the time, coders want to animate with code when using the Unity animation system is a much better solution. So why is it better? For one thing, the animation is usually better, and it will be less prone to bugs. And perhaps most importantly, it will enable an artist or an animator who may be skilled at animation to control the animation, which is pretty much as it should be, right? So the rule of thumb is to maybe use code to animate things that are very simple, like simply rotating, cycling, or something like that. Or for something that's very complex, like complex procedurally generated animation, or data-driven simulations, things like that. For most other cases, I recommend using the Unity animation system, and then using code to trigger transitions in the state machine animator. So let's check out the Unity animation system. The animation system lets you quickly set keyframes on any object and interpolate between them to make things change over time. It's a really nice system, and once you get used to it, you can do almost anything you need. It's always a good idea to stay organized in Unity. So first, create a new folder under Assets called Animation. And be careful to place all your animation clips and animators in this folder. You'll learn about what those are in a minute. Select any object that doesn't have any animation on it, and open up the animation window, which you can open from the Windows Animation menu. I like to keep the animation window docked with the game and console. Select your object. With the animation window open, you'll see the big Create button. Hit that. You will be prompted to save an animation clip. Name your clip, start position, for example, and save it in your animation folder. A lot of things just happened in the background. Notice that your selected object has a new component, an animator component, and it has a new controller named after the object name. It should be placed in the same animation folder as the initial clip. The animation controller manages the transitions between multiple animation clips using a state machine. Also notice that the animation window has changed and now has a timeline. With the object selected, your animation clips can be found with the drop-down on the left of the animation window. You can use this drop-down to create new clips as well. If you select on an animation clip, like the one just created in your projects folder, you can turn on-off looping in the inspector using loop time. Looping is the default. The timeline is set to be in seconds by default, but can be switched to frames if you need that. You can navigate the timeline by zooming in and out with the scroll wheel and click with the scroll wheel to pan. Left mouse click on the timeline to move the playhead to that position. You can hit Add Property and select something to animate and create a keyframe at the current position of the playhead. But a very nice and easy way to do this is to use the record function. Set your playhead to the start at time 0. Turn on the record button. Now anything you do to that object or its children will be recorded as a keyframe at the current position of the playhead. The workflow is to set the playhead in time and change something and repeat to create animation. When ready, you can click and drag in the timeline or hit the play button to see your animation. Under Add Property, you will find a lot of interesting things to animate. For any of these, you can hit the plus sign on the right to add it as a property you want to set keyframes on, and then animate them. You can directly change the parameter values on the left, probably as you would expect, or you can use the record button. Remember to turn off the record button when you're done. You can select and move keyframes as you would expect. Often you will want to hold an animation. You can select a keyframe and copy and paste that down the timeline somewhere. You can drag select a keyframe range and scale the animation in time. Closer together means faster, and further apart means slower. Often, you will want the last keyframe and the first keyframe to be the same. In Unity, you can simply select the keyframes and copy with Ctrl or Command C, and then move the playhead to where you want to paste, and use Ctrl or Command V. Often you will want to hold an animation, and you can select a keyframe and copy and paste that down the timeline somewhere. Note that you can animate things besides just attributes in the transform, such as color. Easiest way to do this is to select the object and clip, and set the playhead, and then turn on the record button. With the object selected, find the color in the inspector, and jiggle it a little bit to set a key. Then move the playhead a few seconds later and change the color. That's pretty cool, right? If you set the object to be transparent, you can even change the opacity over time. You can even animate binary values like visibility. And use the same process. Set the playhead to the time you want, turn on or off the visibility in the mesh renderer component, or just find the value by hitting Add Property. Note, in this case, the property doesn't blend from one value to another. It just pops on and off at that frame. After you have created some animation keyframes, it's time to explore the very powerful and useful Curve Editor. With an animation clip active in the animation window, the object with the animator must be selected in the hierarchy. At the bottom, you can switch from the dope sheet editor, which shows where the keys are placed in time, to the curves editor, which shows you how the values are changing over time with editable spline curves. These go by many names. Sometimes they're called F-curves or motion curves or animation curves, but if you're an animator, you're probably very familiar with the concept. I think this editor works pretty much exactly the way you would expect if you've used any other vector or spline-based interface. You select a property or multiple properties on the left, and you can open up these to be more specific. Note that X, Y, and Z are color-coded. Inside the graph window, hit F, just like in Maya, to have Unity scale and focus the view on the parameter curves you're interested in, the ones that you have selected. Like in the dope sheet, you can use the middle mouse button to zoom and pan. You can drag select and move or delete keyframes. You can right-click on the curve to add keyframes as needed. Grab and move the keyframe handles to adjust the curve itself. Remember, steep means fast, while more horizontal means slow. You can drag select and right-click on a keyframe to change the keyframe type. Most useful are the bottom settings. Try them out and just see how they work. Broken will create a cusp, while smooth will be continuous. Weighted, my favorite, allows you to drag the handle out to increase the keyframe's influence over the curve in that direction, or drag to make it shorter to decrease the influence. It's the most powerful option. But the others are useful for linear or discrete changes. You can create additional clips by using the drop-down on the upper left where you see the current clip name. There you will find an option to create new clip. Let's create a new clip. Give it a descriptive name and save it in the animation folder. Now, switch views to the animator window. Hit F to center everything. Here you will see a green node that says Entry and a line leading to your first animation clip. You'll also see your new clip as a node without a link. This is a state machine where each animation clip represents a state or a node in the graph. Here you can edit the graph to arrange and sequence your clips, as well as set up conditions for when the animation will transition from one state or clip to another. You can easily trigger these transitions with code. You can click and drag the nodes around. You can select any clip and right-click and choose Set as Layer Default Clip. Now the gold line points to your new clip. When the player starts, this clip will begin. You can right-click on any node and choose Make Transition, then drag the line to another node to create a state graph. This white line turns blue when you select it, and if you hit the delete key, guess what happens to the link? Similarly, you can delete a node, and the clip will disappear, and it will not show up in the animation window drop-down either, but the clip asset will remain in your animation folder. And you can drag clips from your projects folder into the state machine to reinstate those clips. But you have to be a little bit careful doing this between objects that are very different, because then you could end up with some very unexpected behavior. Let's dive a little deeper on those animation transitions. Try creating two clips that have no animation in them at all, just one single keyframe, say position A, and another with a different position called position B. For now, leave the rotation and scale alone, just position the object. Set up your state machine so that position A is the layer default, and there's a transition line, white line, to position B. Then create a transition line back from B to A. Hit the play button and watch your object. Notice that you get some animation for free as your object smoothly transitions from position A to position B and then back again. Try it again, and this time have your animator window visible. You might need to set your game window to play focused, and perhaps move your animator window to see everything at once. When playing, you can see the blue progress line move through your animation states. This is really useful for debugging your animations. Let's look at why this object is animating and not just jumping from position A to position B. In the animator window, select the transition link from position A clip to position B clip, and check out the inspector. Here, in this diagram, you can see that each clip plays for a bit with a transition from one to the other. This often creates confusion for people when the animation does something that they didn't explicitly tell it to do. In general, this default behavior is so that there's a smooth transition from complex animations like running and jumping. For that, it works great. You can control this though. Select one of the transition lines and open up these settings just above the diagram in the inspector. In the DXR development basics video, I went over how you can very easily invoke a transition to happen with code, using conditions and parameters. Sometimes you want the clip to finish completely before transitioning, even if the condition has been met. That's what this checkbox has exit time is for. So uncheck that if you want to allow code to interrupt an animation clip. For us right now, we're interested in changing this transition. Try setting the exit time to 1 and the transition to 0, or vice versa, and play around with these numbers a bit. You will find that exit time will vary how many seconds the clip holds on its position, while the transition time is how long it takes to blend from one clip to the other. You'll notice that if you drag your object to a different position and change its rotation, when you run it, the object will immediately jump to the original animated position and ignore the fact that you had just moved it. However, the rotation will remain. Can you think of why? That's correct. The position of the object is baked into the animation, but the rotation is not, since we're not animating it. To move the animation, you can create an empty. Maybe reset it to the origin, and then parent your object with the animator to the empty. Now you can move the empty and the animation will move because now all the child's transformations are relative to the parent. That makes sense, right? Similarly, if you want to duplicate an object with animation, you will want to duplicate it and then parent it to an empty and position it. Otherwise, you will have two objects doing the exact same thing. Remember this, the animator is the state machine, but the clips are what determine the behavior, the attribute values at a given moment in time. In most cases, your animations will be more complicated and might require coordinating different animations between multiple objects. Here's a good method to avoid a lot of headaches. Instead of creating a lot of animators on many objects, it's usually much better, easier, cleaner, and less buggy to group related objects under one animator that controls them. So you first select the objects you want to animate and arrange them as you want in their starting position, rotation, scale, or whatever state you want, using the normal transformation tools and setting parameters in the inspector. Now, in some cases, you will want to position the objects in their final position instead of their starting position, because sometimes the final position is the critical one. Next, create an empty to be the parent and reset its transform to the origin. Then, after all your objects are arranged, parent them to this empty. And this allows you to put the animation on the top node. So you use the top node to create an animator. And with one animator, control all of the children together. This is very useful. Remember to first place the objects before you parent them. Select the parent node and create an animator. Now, in that animator, you will have access to all the children's parameters. In general, you want to percolate the animator towards the top nodes of any nested objects. If all the animated objects are children and the animator is on the top node, You can now duplicate the parent and move it around to create multiples. If you want to make variations on it, though, you will need to duplicate the animator before making changes, because all copies will share the same animator. It's the same state machine. It's easy, though, to duplicate the animator in the project folder. And then drop that into the animator component. After that, you can add or delete clips to it as you want, without affecting the other object's animation. If you want to change a clip, you will need to duplicate that as well and drop that into the new animator to replace one of the existing nodes. Otherwise, if you change the clip, it will change for all the instances, all the other animators that are using that clip. I hope this helps to clarify things related to animation. In another video, we'll cover more advanced topics, including rigged animations, texture animations, sprite sheets, and more. But this should give you a good start. Thanks for watching.